friends, welcome back to the new video. Today I am going to discuss a new topic of class 10th physics, light reflection and refraction. We can see the objects in the presence of light, although light itself is invisible. So light is a form of invisible energy which produces the sensation of sight. When light emitted by a source of light falls on an object, some of the incident light is returned back by the object. The light returned back or reflected by the object enters our eyes. Hence the object is seen by us. Or we can say that any object which reflects the light falling on it is visible to us. On the other hand, if an object neither emits light nor reflects the light falling on it, then the object is not visible to us. For example, we are not able to see anything in a dark room. We are unable to see anything in a dark room. On lighting up the room, things become visible. During the day, the sunlight helps us to see objects, or an object reflects light that falls on it. This enables us to see things. A ray of light is a path followed by light energy in a transparent medium. A ray of light is represented by a straight line having the sign of an arrow on it in the direction of propagation of light. Using the ray picture of light, we shall discuss the phenomena like reflection of light, refraction of light, and the formation of images by spherical mirror and lenses. Now the first topic is reflection of light. The reflection of light from a surface is similar to the bouncing back of a rubber ball after striking a wall. Or we can say that the process of sending back the light rays into the same medium which fall on the surface of an object. The reflection of light from a surface is similar to the bouncing back of a rubber ball after striking a wall. The process of sending back the light rays into the same medium which fall on the surface of an object is known as reflection of light. From figure first, we can see that the rays of light falling on a surface of mirror and get reflected to the same medium. This process is known as reflection of light. A surface which reflects the light is known as a reflector. The polished metal surfaces are good reflectors like silver. There are two types of reflection. First is regular reflection and second one is diffused reflection. When a parallel beam of light falls on a smooth and highly polished surface, then the reflected beam is also parallel and directed in a fixed direction. Such reflection of light is called regular reflection. From figure first, we can see that the rays of light follows a systematic pattern after reflection. That is regular reflection. Basically, this type of reflection used in searchlight, automobile headlights. Figure second is an example of diffused reflection. That means when a parallel beam of light falls on a rough surface, then the reflected light is not parallel but spreads over a wide area. Such reflection of light is called diffuse reflection. That means diffuse reflection does not follow the systematic pattern after reflection. Now the next heading is laws of reflection. First law of reflection. Angle of incidence is equal to the angle of reflection. And second law is the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. Laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. Next topic is image. So generally, what is image? When we stand in front of a looking mirror, we see our face. The picture of our face in the mirror is known as the image of our face. Images are of two types. First is real image and second is virtual image. A real image. When a beam of light from an object actually meets at a point after reflection, then the image of the object formed at that point is known as real image. Virtual image. When a beam of light from an object does not meet at a point but appears to diverge from it after reflection, then the image of the object at that point is known as virtual image. A virtual image cannot be obtained on a screen. Next topic is properties of the image. Image formed by a plane mirror is always virtual and erect. The size of the image is equal to that of the object, and the distance of the image behind the plane mirror is equal to the distance of the object from the mirror. Real image is formed in front of a mirror and it is always inverted. Next, spherical mirror or curved mirror. A mirror whose reflecting surfaces are spherical. There are two types of spherical mirror. First is concave mirror and second is convex mirror. First is concave mirror, a spherical mirror whose reflecting surface is curved inwards. That means outer surfaces is silvered and the inner surfaces act as a reflecting surface. And convex mirror, a spherical mirror whose reflecting surface is curved outwards. That means whose outer surface act as reflecting surface and the inner surface is silvered or polished. Concave mirror converges a parallel beam of light falling on it, so concave mirror is also known as convergent mirror. And convex mirror diverges a parallel beam of light falling on it, so convex mirror is also known as divergent mirror. So next, important terms in respect of spherical mirror. First is pole, the center of the reflecting surface of a spherical mirror. It lies on the surface of the mirror. Second is center of curvature, center of the sphere from which spherical mirror is made of. A center of curvature is not a part of the mirror. C lies outside its reflecting surface. In concave mirror, C lies in front of the reflecting surface. In convex mirror, C lies behind the reflecting surface. Next is radius of curvature, the distance between pole and center of curvature. Principal axis, a straight line passing through the pole and the center of curvature. Principal axis is normal to the mirror at its pole. Next is principal focus. Rays parallel to the principal axis are reflected and meet at principal focus. Next is focal length. The distance between the pole and the principal focus of a spherical mirror is called the focal length of the mirror. It is denoted by F. And next is aperture. The diameter of the reflecting surface of a spherical mirror is known as aperture. Define the principal focus F of a concave mirror. A point on the principal axis of a spherical mirror where the rays of light parallel to the principal axis meet after reflection is known as principal focus. Next topic, relation between focal length and radius of curvature of a spherical mirror. The radius of curvature is found to be equal to twice the focal length. That means R is equal to 2 times of F, or F is equal to R by 2. Is also true for both the mirror, concave as well as convex mirror. Let us take an example. The radius of curvature of a spherical mirror is 20 cm. What is its focal length? We know that relation R is equal to 2 times of F. That means focal length F is equal to R divided by 2. That is equal to 20 upon 2 is equal to 10 cm. Next is find the focal length of a convex mirror whose radius of curvature is 32 cm. The next topic is rules for obtaining images formed by spherical mirrors, or representation of image formed by curved mirror using ray diagrams. First rule is any incident ray of light traveling parallel to the principal axis passes or appears to pass through the principal focus of a spherical mirror after reflection. In figure first, a ray of light which is parallel to the principal axis strikes a reflect surface and gets reflected from the concave mirror, and it will passes through the principal focus. In second figure, a ray parallel to the principal axis after reflection appear to diverge from the principal focus in convex mirror. Next rule, any incident ray of light passing through the focus of a spherical mirror travels parallel to the principal axis after reflection. It is vice versa of the first rule. That means any type of incident ray of light passing through the focus of a mirror travels parallel to the principal axis after reflection. Third rule is a ray passing through the center of curvature of a convex mirror and concave mirror. After reflection, it is reflected back along the same path. That means the light ray retraces its path after reflection because the incident ray falls normal to the reflecting surface. And last rule is, if a ray of light is incident at angle on the pole of a mirror, then it will also reflect at the same angle and will follow the laws of reflection. So these are the basic rules for formation of image. Now next topic is image formation by curved mirrors. First is concave mirror. Now we will learn how to get image of an object at different position. First case, when object is placed at infinity. Consider an object lying at infinity. The rays of light from infinity travel parallel to the principal axis according to rule first. These rays of light after reflection from a concave mirror intersect each other at the principal focus of the concave mirror. Hence, a point-size image of the object is formed at the principal focus of the concave mirror. Hence, the image formed is highly diminished, and the rays of light actually intersect each other at a point. So, the image formed is real, and real is always inverted. Now, second case of image formation by concave mirror. When object is beyond the center of curvature of a concave mirror. That means object is placed between infinity and center of curvature. Same rule we will apply in this case. To get an image of object, at least two parallel rays required to us. One is parallel to the principal axis, which is passing through focus after reflection, and second is passing through focus, but after reflection it will passes through parallel to principal axis, and these two reflected rays are meet between F and C. The size of the image is less than the size of the object. So the nature of image is real and invert and diminished. Next case is when object is placed at a center of curvature. This is the case where the size of object is equal to the size of the image. Consider an object placed at the center of curvature C of a concave mirror. A ray of light from point C of the object travels parallel to the principal axis of a concave mirror. According to rule first, this ray of light after reflection from the mirror passes through the focus of the mirror. Another ray of light from point C after passing through the focus F strikes the mirror. According to rule second, this ray of light after reflection travels parallel to the principal axis and intersects the first reflected ray at point C dash. So the image is formed at the center of curvature of the mirror. The size of the image is same as that of the size of the object. The image is real and inverted. The next case, when object is placed between center of curvature and the principal focus of a concave mirror. In this case, the image is formed beyond the center of curvature of the mirror. You can see the figure. The size of image is greater than the size of the object. So image is enlarged or magnified, and the nature is real and inverted. Next case, when object is placed at focus of a concave mirror. Let us consider an object placed at the principal focus of a concave mirror. The rays of light from the object travels parallel to each other after refracting from the mirror. These parallel reflected rays intersect each other at infinity. We are assuming that the nature of these rays are parallel but converging, so it will meet at infinity. So the nature of image is real and inverted, and the size of the image is much greater than the size of the object. Hence, it is highly magnified image. This is the last important and slightly different case of concave mirror when object is placed between focus and pole. In this case, reflected rays never intersect each other and both have divergent nature. So it will never meet in real. So in this case, we didn't get the real image. The rays of light from the object after reflection from the concave mirror appears to meet at point behind the mirror. Therefore, a virtual and erect image is formed behind the mirror. The size of the image is greater than the size of the object. So the virtual image formed is magnified. So these are some cases of image formation by a concave mirror. The difference between real image and virtual image. Light rays actually meet to form a real image. When light rays appears to meet to form virtual image, the image is generally inverted. Virtual image is generally erect. A real image can be obtained on the screen. Virtual image cannot be obtained on the screen. Real image is in front of mirror and behind the lens. Virtual image is behind the mirror and in front of the lens. Example of a real image is cinema screen, and example of virtual image is our image in plane mirror. The next question is, the image formed by a concave mirror is observed to be virtual, erect and larger than the object. Where should be the position of the object? A. Between the focus and center of curvature. B. At the center of curvature. C. Beyond the center of curvature. D. Between the pole of the mirror and its focus. So the answer will be between the pole of the mirror and its focus. Now the uses of concave mirror. Concave mirror are used in motor headlights, searchlight and vehicle headlights and torches to get powerful parallel beams of light with the help of reflector. We know that the beam of light from the bulb after reflection from the concave mirror goes as parallel beams. They are often used as saving mirrors to see a larger image of the face. The dentist used to see large image of the teeth of patients. And large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Next topic is image formation by convex mirror. Convex mirror always produces a virtual image. There are only two cases by convex mirror. First is when object is placed at infinity. Position of image at the focus. Size of image highly diminished. Nature of image erect and virtual. And the last case is when object is placed anywhere on the principal axis. Image position of image between pole and focus. Nature virtual, erect and diminished. Now the uses of convex mirror. Convex mirror are commonly used as rear view mirrors in vehicles. These mirrors are fitted on the sides of the vehicle, enabling the driver to see traffic behind to facilitate safe driving. Convex mirror enable the driver to view much larger area than plane mirror. Now the question is, why do we prefer a convex mirror as a rear view mirror in vehicles? The simple answer is a convex mirror forms an erect and diminished image of the object behind the vehicle. So the field of view behind the vehicle is increased. Next question is, no matter how far you stand from a mirror, your image appears erect. The mirror is likely to be. The simple answer is option A and option C, because in these cases we get virtual and erect image. Next question is, name the type of mirror used in the following situation. Question A. Headlights of a car. Question B. Side rear view mirror of a vehicle. Question number C. Solar furnace. The answer is question A. Concave mirror. The light source is held at the focus of the mirror. On reflection, a strong parallel beam of light emerges. Answer of B. Convex mirror. Field of view is larger and it forms virtual erect and diminished image of object behind. Answer of C. Light from the sun on reflection from the mirror is concentrated at the focus of the mirror producing heat.